All right, so today what we're going to talk about is electron configuration, okay? And it's not anything super hard, but you do have to pay attention. But once you pay attention, you'll catch on to the trend, and it's very easy, okay? So basically, we've been talking about the electron. This whole unit has been on electron. We've done Bohr diagrams where we show where the electrons are and what the nucleus look like. We've done Lewis dot where we show just the valence electrons. Anybody remember what valence electrons are? Which ones are those?
The electrons on the one electron on the ring.
The electrons on the which ring?
The most outer ring.
Yes, exactly. The ones on the outermost ring. Okay. So this is stuff that's gonna be on your test, and I'll make you a list. But Lewis dot diagrams, the Bohr diagrams. We talk about electrons acting as waves and how much energy they carry and the frequency. So now we're going to talk about electron configuration. Electron configuration is kind of like the address of the electrons, okay? So when we did Bohr diagrams, we kind of showed where they were, okay? The electron configuration is kind of like the address of where they are, and it tells us how the electrons fill up the rings or the orbitals, okay? So this very beginning sentence here says, so I'm looking right, let me annotate while I'm doing this, okay? All right, so I'm looking right here. It says an electron configuration is simply a list of the orbitals that contains electrons for a given element, okay? So we haven't really talked about orbitals, but we're gonna talk about that right now, okay? So this is the part where I'm gonna show you the periodic table and we're gonna figure out how to divide it up, okay? So let me go to this screen. All right. All right, so electron configuration, or orbitals, all right? Orbitals are like where the electrons are housed, okay? So it's like their house, basically. When we're talking about orbitals, there are different shapes for orbitals, okay? So if you think about an electron living in a house, it's like different houses. So I don't know, maybe it's an apartment and then maybe a one-story house and then a two-story house in a mansion, okay? It's just different shapes. So I want to show you the different shapes first, all right? So you have s orbitals, okay? S orbitals. So these are the first two blocks on the periodic table. So you should see right now that it's highlighted pink, okay? Now I want you to look, okay? I want you to look at this right here. Okay, so there's this big blue thing in the corner. Everything that has an S-shaped orbital, okay, looks like a sphere. Okay, the only difference is maybe it gets a little bigger. Any thoughts on why it would get bigger as I go down? So notice how it is here, here. Any thoughts on why it would be getting bigger as I go down? Think about an atom.
Because there's more electrons.
More
The lower you go, the more electrons.
The more, what else are you getting as I go down? Like, what's the difference between
more protons and neutrons as well?
More, I heard somebody said more rings. You also got more rings, right? Think about when we draw our Bohr diagrams, right? When they get bigger, if they have more rings, right? All right, so yes, you do have more electrons. Remember, electrons are super tiny, but yes, you got to get those electrons on those rings. So as you go down, you get more rings, okay? So this is, again, the s orbitals. They look pretty simple. They look like a circle. This is just the inside of it. Then I like to think of these as neighborhoods. So this is the S neighborhood, okay? Then if we go over to the P neighborhood, they're all the way over. So they're everything past the valley, okay? Past the valley, except for helium. If you notice, helium should be right here on your periodic table, but it's over here, okay? So the P block over here, let's look at how they look. They look kind of like a dumbbell, okay? So they look a little different. It's like two spheres put together. And again, as I go down, you can see they get bigger. Okay, again, I'm looking right here. All right, so if I go here, all right, they just look bigger. Okay, and really going across, they just kind of rotate on the axis, like how they look different in shape. Okay, all right, so this is the P neighborhood. The houses in this neighborhood are a little bit fancier. Okay, all right, then we have the D neighborhood. All right, these look even fancier. All right, so they They'll get bigger. They look like almost two overlapping dumbbells. They're kind of weird, super kind of weird. All right, so these are the houses in the D neighborhood. And then the last one is the F neighborhood, okay? These houses are insane. They look crazy. Like, you look at them from the side, they look weird, okay? So this is what these look like. All right, now, so what we're gonna do in a second is I'm gonna get you to label your periodic table by neighborhood. So you'll label like the S neighborhood, the P, the D, and the F. Now, if you notice on the D neighborhood, there's two green blocks that are all the way down at the end of the F neighborhood. Let me show you why. Realistically, if we put the periodic table extended out, okay, so this is a condensed version of periodic table. This is the version we always see in our classroom. But that's because it will be very hard for me to put this version on my wall. Okay, that's really what the periodic table looks like. But that would cover like my whole whiteboard. Like I wouldn't even have room to write anything, okay? So anytime you see a version of the periodic table, it usually does have the F block at the bottom, almost always, okay? But really F block is there. So what I want you to do now, I'm gonna take this back this way, okay? This is where I said you can do if you don't have your periodic table, you can do a quick sketch like this, okay, of the periodic table. And then I want you to go in and label. So I'm going to put it back up, but remember your S block is over here. You can just say this is S. You don't, doesn't matter what color, you can say this is D block, okay? And then, oops, yep. And then be careful when you get ready to label on yours. If this is P block, everything is P except for this one up here. Remember, this one is a S1, okay, because this is helium. All right, and then you can label your F block. So I'm going to put back up the website periodic table so you can see the different neighborhoods, all right? And that's what I want you to do right now. So I'm going to put back up. Let me share. There we go. All right, so here is your S neighborhood. I'll let you do that one. So it's everything including helium. So if you don't have to have colored pencils, you can just kind of box it off if you need to. All right, here's your, here's your P block. So that's all the way, or I can do D next. Does it matter? I'll leave it on P. All right, here's D block. D block is that center one. And then if you look at the bottom of yours, it's number 71 and 103 on the bottom of yours. So 71, 103, and then all those in the middle. Yeah, that one's D. The middle one is D. And then F block is down at the bottom. F block. right, so I'm just gonna take it off so you can see all the colors again. So this, what it should kind of look like, S, P, D, and F. And this is, you have to know this for us to get ready to do what we're about to do. All right. All right. Hopefully everyone's done labeling. If not, there's a little bitty one on my sheet that I'm about to switch to. All right. So now I'm gonna come over here. All right. So again, when we draw our board diagram, it's kind of like a visual representation of this. So we're gonna think of an electron configuration like an address. So for instance, if you gave somebody your address, what's something you would have to give them so they know where you live? You gotta give them a street name.
The street number.
Gotta give them the number. What's one more thing you'll have to give them?
Address of the house.
Okay, what parts of your address? So we got a street and the house number. What else would you need?
The city.
Okay, you can do a zip code or, yes, exactly, a zip code or a city, okay? So we're gonna do something kind of similar, okay, for the electron configuration. So let me tell you what parts of the address you need, okay? I'm gonna make this a little bit bigger, all right? When you're given the address for an electron, the first thing you need is the street that it lives on. So this is what we're gonna use for the streets. We're gonna say how many rings it has is gonna be the street. So for instance, okay, we're gonna say if it's on street 1 or street 2, 3, 4, 5, 6, or 7, okay? Now remember, that's just the number of rings. And remember, this is going this way. So for instance, on your periodic table, helium is over here, okay? So there's only hydrogen and helium on the first street, okay? On the second street though, you got lithium and beryllium, and then you keep going over, you got boron, carbon, nitrogen, oxygen, fluorine, neon. Everybody understands streets, right? It's just the rings, okay? So that's gonna be the first part of, we're gonna say ring or street. That's gonna be the first part of the address. All right. The second part of the address, let me erase some stuff here. Okay. The second part of the address is going to be the neighborhood. So the neighborhood is gonna be the stuff that we just did. That's like S, P, D, or F. Okay. S, P, D, or F. So that's gonna be this stuff right here. All right. So that's gonna be the second part. So we're gonna say neighborhood. All right, I'm just gonna say neighbor. All right, this is neighborhood. All right. And then the last part is gonna be the house number. So let me show you what I mean by house number, okay? So then house number. All right. If you are in the same neighborhood, so like let's look at the S neighborhood. S neighborhoods only have 2 houses. You're either in the first house or the second house. First house or the second house. First house or the second house. First or second. What about in the P neighborhood? How many houses do you have in the P neighborhood? How many? 6. So remember, P neighborhood is these kind of greenish blue ones. So you got 1, 2, 3, 4, 5, 6. In the P neighborhood, these all have 6 houses. 1, 2, 3, 4, 5, 6. So for example, if I look at aluminum, he lives in the first house. But if I look at sulfur, he lives in the 4th house. Okay. Then what about the D neighborhood? Somebody online tell me how many houses are in the D neighborhood.
10.
10. Very nice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, all the way down. 6, 7, 8, 9, 10. And then how about the F neighborhood? Mhm.
14.
Yep. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right. So now that we know how to give the address for the electron, okay, we're gonna get ready to start. All right. And then it's easy at first, but there's one small catch, okay? When do we give the address for whatever element? Let's just say it was oxygen, okay? Really, I have to give the address for everybody up through oxygen, okay? And I know that sounds weird and sounds long, but once we start doing them, you're gonna be like, oh, okay, I got it, okay? So we're gonna start slow and low, like hydrogen and helium, and then we'll build our way up. All right, so let's start with hydrogen. All right, based off of this, based off of the street, the neighborhood, and the house number, let's see if we can figure out what the address is for hydrogen, okay? What street number does hydrogen live on? Or how many rings does it have?
1.
1. Excellent. Everybody agree with that. All right. It's on the first street, on the first row. And then what neighborhood, S, P, D, or F, does hydrogen live in?
S.
Very nice. Lives in S. So we're going to do that. And then what house number? 1 or 2? Because we only got 2 houses. 1 or 2?
1.
1.
Very nice. 1. That is hydrogen's address. 1S1. Okay. That is hydrogen's address. All right. Just easy, right? Easy. All right. All right. Let's do helium. All right. Street number? Still 1. All right. What neighborhood? S.
S.
And what house number?
2.
2. Excellent. Excellent. All right. So that's how easy it is. Now here's the small catch. So remember I said, if you go past that, you really have to give the address for everybody behind it. But here's the great thing, okay? Let's just say we were doing oxygen, okay? All right. Here's what I can do. Instead of saying 1S1 and 1S2, because I have to, for me to do oxygen, okay, let me erase some stuff here. All right, for me to do oxygen, let me show you what I have to do. I have to account for everybody who lives before oxygen. So what that means is I have to account for hydrogen and helium, okay? And then I have to account for lithium and beryllium, boron, carbon, nitrogen, and then I can stop at oxygen. So let me show you how that's gonna work, okay? It's not as bad as it seems, because if I move out of a neighborhood or I move to another street, I can just list the address of the last house, and that covers everybody before that. So in other words, if I want to cover, so I'm gonna erase this again, all right? The first ones I have to cover, you have to go in order, okay? We're trying to get to oxygen, all right? So for me to cover hydrogen and helium, I can just give the address for helium. Well, what did we say the address for helium was? 1S2. All right, so this 1S2, that covers hydrogen and helium. Excellent, okay? All right, now I'm trying to get to oxygen. There's nobody else left on the first street, so I'm gonna go to the second street. I can cover everybody on the second street in the S neighborhood if I give the address for beryllium, okay? So what would be the address for beryllium so I could cover lithium and beryllium? Excellent. They're on the second street. They're in the S neighborhood, and beryllium's in the second box. So that now covers lithium and beryllium, okay? Okay, everybody with me so far? If you're getting a little lost, don't worry, we're still gonna go slow, okay? All right, so now somebody online, I'm trying to get to oxygen. So now you can give me the address just for oxygen. So can somebody online tell me what street number oxygen lives on?
4.
Or what street number? Street number, not house number.
2.
Oh, shoot. 1.
Street. Remember
2.
the little, yes, it is 2. Ryan, what you gave me was the house number. So Ryan, you're right, the house number is 4, but now I need the neighborhood. What's the neighborhood, guys? SP, D, or F?
P.
It is P. So this is the address for oxygen, okay? So this is what I did. 1s2 covered hydrogen and helium. 2s2 covered lithium and beryllium. And then 2p4 takes me right up to oxygen, okay? 2p4 takes me right up to oxygen, okay? All right, so let's try sodium. Oops, let's try sodium. Sodium is Na. All right, I'm gonna go in and erase some stuff here. And then I'm gonna show you a way to check yourself to make sure you're doing it right. All right, so sodium. Skylar, are you there?
Yes.
Okay, Skylar. So sodium. So here's the good thing, guys. The address for all that other stuff, the stuff in the beginning, doesn't change. So Skylar, if I wanted to cover the address for hydrogen and helium, what would I write?
1s1 and 1s2.
Yeah, but I can just do just one of them. I can do just the helium box, and that'll cover hydrogen and helium. So what do you want me to write? 1s what? 1s what? Can you give me helium's address?
1s2.
Very nice. 1s2. So that covers hydrogen and helium. Because helium's the last box in that neighborhood. So it's like saying, oh, everybody on this street in this neighborhood. That's what that's saying. All right. So that's sodium. All right, Jinde. We've covered everybody on the first street. So now we got to start at the second street. I need to cover lithium and beryllium. What do you want me to write? Very nice. Jinde said 2s2. He's on the second street. This is the second street. He's in the S neighborhood. Okay. And he did beryllium because he's the last house in that neighborhood. And so that will cover lithium and beryllium. Okay. All right. So that's 2s2. Now remember, you got to get everybody on the second street. So we got everybody on the second street in the S neighborhood, but there's still people on the second street in the P neighborhood, okay? Camille, do you want to try this neighborhood? So I need to cover, I'm trying to get to sodium. This is who I'm trying to get to. So I really can cover all these guys if you give me the last house in the neighborhood. So tell me the street number first. 2, and then what neighborhood is it? Very nice. And then Neon, he's the last house in the neighborhood. What's his house number? 6. Excellent. All right. She gave me Neon because he's the last house in the neighborhood. So the 2p6 covers, this is like saying 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. All right. 2p6 covers everybody in that neighborhood. Okay. And now we are at sodium. So somebody needs to give me the address just for sodium because that's where we're trying to stop. What street number? 3 is the street number. And then somebody online, what neighborhood is sodium in? Sodium's right here.
S.
Very nice. S. And then what box number or house number is he at?
1.
Excellent. 3S1. That is sodium's address. Okay. All right. I want you guys to try. You guys are doing. Wait, maybe I was really tired yesterday too. All right. I want you guys to try chlorine. Okay. Oh, wait. I'm going to show you the check. All right. So let me show you something cool. Cool way to check yourself. Okay. So we know that okay, let me highlight these. Okay. We know that this number, the 1 and the 2 and the 2, that tells me the ring, okay? And then we know that the letters tell me the shape of the orbitals. Guess what these little numbers tell me? These tell me the number of electrons. So if I add up these circle numbers, what does that equal to? 8. Guess what oxygen, guess how many electrons oxygen has?
8.
So that's how you check yourself, okay? Because I didn't say it had a charge. So just like here, hydrogen was number 1, it had 1 electron. Helium was number 2, he had 2 electrons. Sodium is number 11, and I got 2, 4, plus 6 is 10, plus, oops, plus 1 right here. That's 11 electrons. That's how you can check yourself, okay? All right, so I want you guys to try chlorine. Let's see how you do on that one, okay? Try that one, and then we'll go through it together. All right, looking good so far from what I can see and hear. Anybody online want to give it a go? I can help you out if you want.
Yeah, my computer glitched out. I didn't know what happened, so I missed out on a lot.
Okay, well, okay, so see if you can follow along when we do this. Was somebody else gonna try it though?
I got it.
Okay, let's go, Lexi.
So I get one S2.
Okay, so pause just for a second. 1S2, and I'm just doing this for people who are missing. So 1S2, okay, that's the first street, the S neighborhood, and there's 2 blocks. This covers hydrogen and helium. Very good. All right, keep going, Lexi.
2S2.
2S2. We're done with everybody on the first. So now we're on the second street, okay? The second street, and then S neighborhood still, he covered lithium and beryllium by saying 2S2, okay? Fantastic. Go ahead, Lexi.
So I get 2P6.
2P6, there's still houses on the second street. All right, so he just went to the last house in the neighborhood. So 2P6, 2, this is the P neighborhood over here. P6 covers boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, go ahead, Lexi.
I got 3S2.
Yes, 3S2. So now that everybody's done on the second street, he's on the third street. He said 3, this is the S neighborhood, 2 boxes, 3S2, that covers those 2, okay?
And 3P5.
And then 3P5. So now he's going just up to chlorine because that's the one I asked you for. So then he said he's on the third street still. Now he's in the P neighborhood, 3P. And then he said 1, 2, 3, 4, 5. Excellent job, Lexi. Very nice. All right. And so how could we check to make sure Lexi is right?
Oh, then add the numbers. Add the little
Yep.
numbers.
Excellent. Add the little numbers. So you're looking for 17 because that's chlorine's atomic number. So 2 plus 2, that's 4, plus 6, so now we're at 10, plus 2, that's 12, plus 5, 17. 17 electrons. Excellent. Okay. So let me make one connecting part for you, and then I'm going to connect this to board diagrams just for a second. And then I'm going to teach you one more thing, and then we'll do like 2 practice problems, and then we'll be done. We're still going to do, you guys are light years ahead of the other class. I don't know what happened. Maybe I just taught it really bad yesterday, or maybe maybe it's because it was Monday. But we'll do a couple practice problems, and then we'll still just do our work on Thursday. All right, so I'm going to erase this. So let me talk about the chlorine one. We just did that one. And let me just show you how it connects to board diagrams, okay? All right, if we were to draw a board diagram for chlorine, all right, chlorine is right here. So it has 17 protons. It probably has, let's see, 35 minus 17, like 18 neutrons, and then it's gonna have 17 electrons, okay? So I would draw 17 protons. You don't have to do this part. I'm just showing you how it connects. 18 neutrons, that's my nucleus, okay? And then I will have how many rings? Is it 3?
3.
3.
3. All right. 3 rings. All right. So I did show you guys a certain way to draw board diagrams, and that's correct. Okay. But let me show you now with the orbitals. Okay. All right. 1s2. On the first ring, there are 2 electrons, and they both are the shape of S. 2 electrons. One. So I could put them together. I'm still going to separate them. That is your 1s2. Okay. 2s2. That says only 2 electrons. How many is the second ring supposed to be able to hold them?
4.
8. 8.
8.
Yeah, it should be able to hold 8. Remember we said the first ring can hold 2, second can hold 8, third can hold 8. So this only says 2 electrons. One, even if we say there's 2 s electrons, even if we put them together. So where are the other ones at? Well, let's keep going. 2p6. Oh, so there are 6 more electrons on this ring. They're just a different shape. So you have the 2 s electrons are like just the circles, and then the 6 ones are that different shape. So here's your 1, 2, 3, 4, 5, 6. That's your 2p6. Okay. So it just means those are shaped differently than the s electrons. Okay. 3s2. 1, 2. So let's just say those are shaped like that. 3p5. 1, 2, 3, 4, 5. That's exactly how your board diagram would look for chlorine. Okay. So that's the connecting piece. They're connected. Okay. It's just telling you, hey, this is the shape of the electrons that are on this ring, and this is how many you have. All right. So how are we feeling so far? If you are feeling like, hold on 1 second, let me put it online. Let me make my other computer so no one can see your chat. If you are completely lost, give me 1 second. Don't put it in the chat just yet. All right, if you are completely lost, I need you to put it in the chat to me right now, just so I know moving forward, okay? All right, and then what we're gonna do, I'm gonna show you one more thing. We're gonna do 2 practice problems, and then actually let's take a 10-minute break right now, okay? So let's take a 10-minute break, and then I'll come back. I'll show you 2 more things, and we'll be done, okay? All right, let's take a break. Jinde, you are in charge of reminding me to start back recording, okay? 10-minute break, guys. So let's just come back at let's do 8:50. All right, so here's the last thing I want. I got one more small catch for you, and then after that, we will be done. Okay. So someone asked me a good question in the chat. I just want to address that really quickly. They said, why can't, so for instance, with chlorine, they said, why can't I just say it's at 3p5? Okay, and that's true. So if I, for example, when I give you your quiz on Thursday, I may give you a long configuration, like say for instance, like down, let me use the spotlight here. So for instance, down here, let me make sure you guys can see that. Okay, good. Down here, realistically, you could just look at the end. If this says 4p4, realistically, I can go up here, go to 4, go over to p and count 4 boxes over and know what it is. But, oh crap. Oh wait, Lexi, you can't hear, can you guys hear me?
I can hear.
Okay. Lexi, maybe log out and come back. Sorry, somebody was saying they couldn't hear me. All right, so, but, okay, one of the points of an electron configuration, so yes, you can use just the ending, that's a good point, to figure out what element is, but the whole point of the electron configuration is so someone can see, oh, how do the electrons fill in? And so when I look at this, I can say, oh, on the first ring, there's 2 electrons and they're this shape. On the second ring, there's 2 electrons and they're this shape. And then also on the second ring, there's 6 more, but they're a different shape. So this sequence tells me how the orbitals feel. So like right here in this part, the orbitals of an atom feel in a specific sequence, because they feel that way. Like when we were drawing our board diagrams, we didn't start out drawing electrons on the third ring and then go back to the first ring and then go to the second ring. This tells us exactly how the electrons fill up the atom. Okay, so that was a really good question. I thought that was a good question. Okay, all right. So the next thing I want to talk about is, I'm going to be honest with you, I lied to you guys earlier. All right. I lied about one thing. So remember when we said we were doing board diagrams, okay? And we said the first ring could hold 2. And then how many rings did the second one hold? 8. And then the third one?
8.
8. All right. So here is where I lied. Okay, somebody needs to write me in the chat. I'm just making sure. Okay. All right. Realistically, okay, the first ring can only hold 2, okay? The third ring can only hold 8, but the second ring, but the third ring actually can hold 18, okay? So let me explain what that really means. That means there's an additional 10 electrons somewhere that we didn't realize. So remember when I said we were doing board diagrams, I said I am never gonna go past calcium, okay? And that's because after calcium, the electrons get lazy, okay? And there's really more spots that can hold electrons, but who wants to draw like 18 electrons on a ring, okay? So here's what I need you to label on your periodic table, okay? These street numbers here that we were talking about earlier, all right? These street numbers here that we talked about earlier, right here, are true, okay? First street, second street, third street, fourth street, fifth street, sixth street, seventh street. But, okay, this D block is a little funky, okay? This D block is a little funky. So realistically, the D block is actually a street behind, okay? So down here, where you have between 20 and 21, I want you to write the number 3, okay? Because when you get to the D block, the D neighborhood, those guys actually live on the 3rd street, okay? And then right here, these guys live on the 4th street, okay? So on your periodic table, in between 20 and 21, you're gonna write 3, and between 38 and 39, you're gonna write 4, okay? And realistically, this is 5 and this is 6, okay? Now, I don't know if I'll go past that, but realistically, F block is extra behind, and this is a 4 and a 5, but I don't think I'm gonna do anything from those, okay? But label those, okay? So now that's just for D block. So for instance, potassium, let me use my highlighter again. Okay. So for instance, potassium and calcium do live on the 4th street. All these guys live on the 3rd street, but then starting back with these guys, they are on the 4th street again, okay? So let's do just like 2 more practices with these and then we'll be done, okay? All right, so I'm gonna do the first one with you, or we'll do it all together. I'm gonna just call on, everybody or call on people to help me fill it in. So it's gonna be like, I'll say, Tasha, what's the first part of the address that I should write, okay? And then I'll go to the next person. So we'll do that, and then we'll do like 2 of these, and then we'll be done, okay? So let's do, how about, okay, how about, let's do copper. See how far you can get with copper, okay? And then we'll do this one together. So I'm gonna pause, I'm gonna let you start copper. Okay, let me show you where copper is. Copper is right here. All right, so it's no different. The only thing that's gonna be different is that when you get to copper, instead of 4D, it should be a 3D, okay? All right, so work on copper, and then we'll do it together. All right, so I'm just gonna call on people. You can tell me what would be next in the sequence. So Janiyah, can you start us off? What would you like to start with? Let me erase this, make it nice and pretty. So I need to cover hydrogen and helium first.
Okay. So it would be 1s1.
Remember,
Wait,
if you're doing, yes, exactly, 2. 1s2. All right. So just again to explain, Janiyah just covered the 1st street. They're both in the S neighborhood. And if she says 2, because helium is the 2nd house, that covers hydrogen and helium. All right. Thank you, Janiyah. Josh, who's next?
2s2.
Very nice. 2s2. 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 All right, Janiyah covered hydrogen and helium. Josh just covered lithium and beryllium. Thank you, Josh. Brandon, you got the next part for me?
Is it 2p6?
2p6. Excellent. 2p6. That covers the rest of everybody on the 2nd street. 1, 2, 3, 4, 5, 6. That covers all of those guys. Okay. Joanna, you got the next part for me?
3s2.
3s2. Excellent. That is now we're on the 3rd street. S neighborhood. Joanna covered sodium and magnesium. Good.
Is the
Julie,
next one 3p6?
Very nice. Who was that? Was that Mariah?
Yes.
Great job, Mariah. 3p6 covers aluminum, silicon, phosphorus, sulfur, chlorine, and argon. Excellent. Julie, how about the next part?
4s2.
Yes, you are right, Janiyah. 4s2. 4s2 would cover potassium and calcium. All right, whoever gives me this ending part, remember you're dropping down a street number, okay? Dropping down a street number.
3d9.
Excellent. 3d9. 3. Okay, 3d9. This is the 3rd street. We're now in D block. 1, 2, 3, 4, 5, 6, 7, 8, 9. Excellent. All right. One more and then we're done. I want you to do bromine. Okay. The only difference is once you live out of D block, you're back on the 4th street. Okay. So once you leave out of D block, you're back on the 4th street. Okay. Only D block drops down. So now you're doing bromine, and then we'll be done for the day. You guys did so good today. Oh my gosh. I feel like my day's gonna be much better. All righty, let's go ahead and finish this out. We can be done for the day. All right, Irvin, how about you start us off? We're trying to do bromine. Let me erase my little slashes here so we can make sure we are getting everything. We are trying to get to bromine, which is number 35. Ooh, and then we can also check. We didn't check last time, but we can check to make sure we are doing this right. So we're trying to get a bromine. All right, Irvin, what's my first thing you want to give me? Excellent. 1s2. That covers hydrogen and helium because they live on the first street in the S neighborhood, 2 blocks. Very nice. Daniela, how about what you got next for me, Daniela?
2s2.
2s2, excellent. 2s2, that will cover lithium and beryllium. Excellent. Jermaine?
I'm gonna be honest. I'm lost, so I'm just trying to like pay attention.
Okay. Jermaine, I need to cover these 6. Can you tell me what street number they live on? What row are they on?
The P block.
What row? What row first?
The first row.
First row, second row, third row, fourth row.
Row.
Second row, what neighborhood? S, P, D, or F?
P.
How many boxes?
6.
6. 2P6. Thank you. All right. Annalise, what you got next? All right, she said 3s2. She is correct. 3s2 would cover sodium and magnesium. Go ahead.
3p6.
Thank you. Thank you, Mariah. 1, 2, 3, 4, 5, 6. 3p6 covers those.
And 4s2, right?
Yes, ma'am. 4s2. All right. Serenity, do you know the next one? We've covered up through 4s2, so I need these guys right here.
Oh, 4d10.
It's
Up.
3D10, right?
Right, Alexi. What'd you say, Alexi?
3D10.
3d10. Don't forget that D block drops down. So this one is 3d10. I'm just gonna put that in a different color. 3d10. All right. So now we just need, so now we've covered 1, 2, 3, all the way through zinc. So now we just need up through bromine. I'll take anybody. Tyson?
3p5.
4P5.
Close. 4. These
4P5.
jump back up. Only D block drops, okay? So then
so
this
it's
is, exactly. So this is 4. It's on the 4th row still. In the P neighborhood. 1, 2, 3, 4, 5. 4p5. Excellent. All right, you guys did really, really good today, actually. Okay. On Thursday, we'll do a quiz, okay? So this sheet is already in OneNote and it's on Schoology. I'll be honest with you, I'm probably gonna pull most of my questions from here if you wanna just take a look at it. That's up to you though. All right, excellent job today, guys.